Hello dears, today I am going to discuss about the one of important topic of wave, that is dispersion of wave. I introduce some small topic of this session. First one is dispersion. I hope all are known about what is dispersion. Dispersion, the phenomenon associated with the propagation of wave through a medium and its dependence on wavelength is called dispersion. So, depending on wavelength, different wave may traveling through a medium in different velocity. The speed of a wave through a medium depends upon its wavelength in that medium. For example, in electromagnetic wave, which can propagate through any medium, like it can propagate through glass, it can propagate through water, it can propagate through crystal, etc. In each and every medium, the wavelength will be different. Accordingly, its velocity is varying. We have phase velocity equal to omega divided by k. We write phase velocity in terms of wavelength and frequency, that is Vp equal to lambda into f. Definitely, in any medium, wavelength is varying medium to medium and velocity and phase velocity varying in medium to medium. Dispersion led to various interesting phenomena. For example, separation of white light into different colors in a prism. From the figure, when sunlight passes through a glass prism, the sunlight split into 7 colors. As light passes through a prism, bending property also varying. Measure of bending is differ, they get diverged. What is the reason for dispersion? The velocity of the wave is different for different wavelength inside the medium because the refractive index affects the propagation of wave. That is the reason for dispersion. For light wave velocity depends on the refractive index. From the figure, violet has least velocity and red has highest velocity. The velocity is high. The red undergo least bending. Violet has least velocity, that is, there is highest bending. There are so many other examples for dispersion. First one is formation of rainbow. When sunlight passes through a water droplets, rainbow will form. Next example is dispersion of light on a CD. On compact disc or CD, we observe that light disperses into 7 different colors. Next example is dispersion due to oil on road. When there is oil spilled on road, we can sometimes see the different colors of white light. Next one is dispersion in a diamond. When light passes through a diamond, the light split into different colors. These are the examples for dispersion. Next topic is dispersion relations. Dispersion relation is determined by the physical properties of the medium, and dispersion relation described the effect of dispersion on the properties of wave in a medium. The relationship between the frequency omega and the wave number k is called the dispersion relation of the medium. In different media, we have different relation. In glass, prism, plasma type material an ionic conducting material, the relation between omega and K will different. It is known as dispersion relation. Given the dispersion relation, one can calculate the phase velocity and group velocity in the medium as a function of frequency. Different media possess different relation. This will lead to different wave behavior. The next topic is dispersive and non-dispersive medium. We can classify the medium into dispersive and non-dispersive. What is dispersive medium? The medium in which wave of different wavelength travel with different velocity is called a dispersive medium. In dispersive medium, it should have a property to disperse. That is it mean. Suppose you pass a collection of wave of in different wavelength in different velocity. It is dispersive medium. Examples of dispersive medium is light wave in glass and electromagnetic wave in plasma medium. Keep in mind one thing, in free space, electromagnetic wave does not show dispersion because all waves travel with same velocity. Next one is non-dispersive medium. What is non-dispersive medium? Medium in which waves travel with same velocity is called a non-dispersive medium. Examples of non-dispersive medium is sound wave in air and light wave in free space. In free space, there is no dispersion. All waves travel through air in same velocity. In a non-dispersive medium, the velocity of wave is independent of wave number k. V equal to omega divided by k equal to a constant. Therefore, omega equal to constant into k. It is only for non-dispersive medium. But for dispersive medium, V equal to omega divided by k. It may not be a constant because there may be some non-linear relation. So, thank you for watching my video.